Swayam Prabha. Digital India. Educated India.
Welcome to the next session on Organic Chemistry 2. In Module 5, we are currently studying about alcohols and ethers. In this lecture 4, we will be studying some worked out examples related to alcohols. I am Dr. Balaji, currently working as Associate Professor in the School of Biotechnology at Jawaharlal Nehru University. This project is sponsored by DTH Swayamprabha, MHRD, New Delhi. So let us look at what are the topics that we will be studying in this particular session. So we will be doing lots of worked out examples or problems related to synthesis of alcohol in this particular session. Let us now study about some of the worked out examples of alcohols and ethers. Before we start our examples, let us find out what are all the ways by which we can differentiate alcohols, that is mainly primary, secondary and tertiary alcohols. The first method what we will see is like the oxidation reaction. The primary alcohol can be oxidized using KMnO4 or potassium dichromate under acidic conditions to give carboxylic acids. And the secondary alcohols undergo oxidation to give ketones. So this way we can actually find out acids are acidic in nature and the ketones are neutral. So we can use some of the experimental method to differentiate between acidic and neutral compounds. So by that we can differentiate between primary alcohol and secondary alcohol. And another method is the iodoform test. In the iodoform test, what we need is the alcohol has to have a CH3CHOH moiety. This moiety should be present in the alcohols. So if this is present in the alcohol, treatment of the alcohol with the sodium hydroxide and iodine produces iodoform. Iodoform is yellow in color, so we get a yellow precipitate. By that we can confirm that the alcohol has a CH3CHOH moiety is present in that particular alcohol can be confirmed. Then the next one is Lucas test. Lucas test is nothing but a combination of hydrochloric acid and zinc chloride combination is treated with various alcohols, and when we treat this Lucas reagent with a tertiary alcohol, we will see immediate turbidity because the reaction produces the chloride. The chloride is insoluble in the solvent medium whatever we are using, that is aqueous HCl conditions. So we see immediate turbidity, so that confirms that the solution has tertiary alcohol. Or tertiary alcohol gives immediate turbidity when treated with the Lucas reagent, that is HCl and zinc chloride. And in the case of secondary alcohol, we observe turbidity, but it takes at least 5 to 10 minutes. That means a slow turbidity is formed. This confirms that the alcohol what we are testing is a secondary alcohol. And if it is a primary alcohol, it does not show any turbidity. In other words, we can say that primary alcohol does not give the corresponding insoluble alkyl halides. And of course, allyl alcohol also reacts like tertiary alcohols, but the allyl chloride is soluble in the reaction mixture, so they also do not show the turbidity. So by that we can differentiate between primary, secondary and tertiary alcohols. And the next test is the Victor-Meyer test. In this particular test, a series of reactions are carried out to find out whether it is a primary alcohol, secondary alcohol or tertiary alcohol. Let us look at one of the number of steps what we follow sequentially. So in the first one, the primary alcohol is treated with the iodine and the phosphorus. It gives the iodo derivative, and the iodo derivative is treated with silver nitrate, so that gives the nitro derivative, and this nitro derivative is diacetized with the nitrous acid, and we get a nitrolic acid. So this nitrolic acid is blue in color, and this on treatment with sodium hydroxide gives a red compound. So by that we can say, by following the sequence of reactions, we can say the primary alcohol gives a red color compound. So this confirms it's a primary alcohol. And when we take the secondary alcohol, we follow the same set of reactions. The treatment with iodine and the phosphorus produces the iodo derivative. This was treated with silver nitrate to give the nitro derivative. This on treatment with the nitrous acid produces a blue color compound which is a pseudo-nitrile, but this does not react with sodium hydroxide. That means no color change is observed. So from this we can differentiate between the primary alcohol, which on treatment of this particular compound with sodium hydroxide produces a red compound, whereas the secondary alcohol does not give any red compound. So we can easily differentiate between primary and secondary alcohols. And when we take the tertiary alcohol, we do not see any blue color, so there is no reaction in this particular nitrous acid does not give any color change. So by that we can also identify tertiary alcohol whether it is present or not. So by that we can, using Victor Mayer test, we can differentiate between primary alcohol, secondary alcohol and tertiary alcohol. So this is another method to differentiate between all the three alcohols. Now let us start our worked out examples one by one. Let us start from Grignard reaction. So using Grignard reaction, can we draw a method to synthesize this particular alcohol? So if you look at very carefully, this is a secondary alcohol. So this secondary alcohol can be synthesized using Grignard reaction. So there are two ways to identify what are all the different starting materials that can be formed. So we can either break this bond as shown here as A, or we can break this side where it is shown as B. So these are all the two different ways how we can break. Basically how we have to break the molecule is the hydroxy derivative has to go with one set of compound. So if we break at A, the hydroxy derivative is present in this part of the molecule. If we break this particular bond, the hydroxy group is present in this part of the molecule. So that means the precursor to the hydroxyl is nothing but the carbonyl compound. Whether it is an aldehyde or ketone can be differentiated based on the number of substituents present. So the hydroxy derivative can be prepared from the corresponding carbonyl compound. So this is what you have to remember. So when we break the molecule, if we break from A side, this particular moiety is going to be the corresponding aldehyde, and if we break from this side, this part is going to be the aldehyde, what we have to choose. So let us see what are all the products. So when we break from the A side, we have the corresponding 1, 2, 3, 4. So butyraldehyde is the starting material and ethyl bromide is the other unit we have. So these two combine to give the corresponding alcohol whatever is given here using Grignard reaction. And if we do the breakage from the B side, then what we have is 1, 2, 3. So 3 carbon propanaldehyde, and we have 1, 2, 3, 4. So butyl bromide. So butyl bromide and propanaldehyde can be used to make this particular alcohol. So by breaking through A or B, we can make the same molecule by two different methods. So in this particular case, we have a secondary alcohol. So when we have a secondary alcohol, the starting material is an aldehyde. So here again aldehyde, this part is also an aldehyde. Let us look at the synthesis of benzyl alcohol. So benzyl alcohol is basically a primary alcohol. So to prepare a primary alcohol, we have to use a formaldehyde as one of the substituent. So then the other part, because here we have only one part, so the bond has to be broken here between the aromatic ring and this particular carbon. So that leads to one of the starting material is the formaldehyde treated with the phenyl halides. It can be bromo. The preferred one is the bromobenzene. So by that we can make use of the Grignard reagent to make the benzyl alcohol. And when we look at this compound, this is basically a tertiary alcohol. So to prepare a tertiary alcohol, the starting material has to be a ketone. So this is the ketone we have to start with, cyclopentanone, and treated with methyl bromide produces this particular corresponding tertiary alcohol. So by this we can actually make by identifying what is the alcohol, we have to choose the correct starting material. If it is a primary alcohol, then formaldehyde is one part, and if it is a tertiary alcohol, a ketone is the starting material. And if we have to use Grignard reagent reaction to prepare this particular alcohol, then this is basically a tertiary alcohol. So we have a phenyl unit one side, we have a methyl group, we have an ethyl group. So these three substituents are present on the carbon, the tertiary carbon. So to make that, we can choose any of the ketone. In other words, the ketone can be from the phenyl group and the methyl group, or phenyl group and the ethyl group, or methyl group and the ethyl group. So all the three combinations of ketones are possible. So the first one is phenyl group and the methyl group combination. The second one is phenyl group and the ethyl group combination. And the third one is methyl group and ethyl group combination. So all the three cases, if you look at, they are all ketones. The other part is nothing but the halogen, the alkyl halide or the aryl halide in this particular case, can be used to make the corresponding tertiary alcohol. So this way you can actually dissect the molecule into different pieces and we can make the Grignard reaction. Now, the next question is a much more challenging one. We have to synthesize this particular alcohol using an acid chloride or ester as a starting material. Now the question is, can we actually make it? Because this is a secondary alcohol. Remember, this is a secondary alcohol and we have to use a acid chloride or ester as a starting material. Can we use Grignard reaction to make this compound? The answer is no, because this is a secondary alcohol. So secondary alcohol cannot be synthesized by acid chloride or ester and a Grignard reagent. So this cannot be used. This compound cannot be synthesized using Grignard reaction starting from an acid chloride or ester. But the same can be synthesized by other means, but we are not concerned about that. Using Grignard reaction and using acid chloride or ester as the starting material, this alcohol cannot be synthesized. Now, another question. Can we synthesize this particular alcohol using acid chloride or ester and the Grignard reagent? So we will have to now find out what are all the different groups present here. We have an ethyl unit here, we have another ethyl unit, we have another ethyl unit. So this has a symmetrical molecule with a 3 ethyl unit. So we have to find out whether it can be synthesized. So in the first step, since it is a tertiary alcohol, we can start from a corresponding ketone, and this ketone can be obtained from this corresponding acid chloride or ester. So in this particular case, yes, this tertiary alcohol can be synthesized from the corresponding acid chloride or ester. So this is the starting acid chloride or ester. This, when treated with this particular ethyl bromide, produces this particular ketone. This can again undergo reaction with this second molecule of the Grignard reagent to produce our tertiary alcohol. So whenever we are using acid chloride or esters, we do need to look at whether there are two groups, similar groups present in that molecule. Only those kind of compounds can be prepared, because 2 moles of the Grignard reagent is required for the synthesis. Now, let us look at this particular example. So in this case, it is again a tertiary alcohol. Can this tertiary alcohol be synthesized using a Grignard reaction using an acid chloride or ester? So in the previous one, we had seen tertiary alcohol can be synthesized provided there is a symmetrical molecule, or 2 units of that tertiary carbon has to be same. But in this particular case, we have a phenyl unit here, we have a methyl here, we have a cyclohexyl unit here. So all the three are different. So can we synthesize? But unfortunately, this product cannot be synthesized. The reason is, although the product is a tertiary alcohol, it is not having 2 groups that are same. So hence two different Grignard reagents are actually required to make the ketone and the final product alcohol. So the product cannot be synthesized by the acid chloride or ester and the same Grignard reagent. So because in this particular case, if we have to use acid chloride or ester, we need the same Grignard reagent only. So by that we can conclude that many of these reactions require some specific set of conditions for the preparation of tertiary alcohols. So this compound can be prepared but using a ketone and a alkyl halide only, but not by the acid chloride and ester. This is not an acid chloride, this is a ketone. So this compound can be synthesized by the Grignard reaction, but it cannot be a acid chloride or a ester starting material. Let us move on to another set of reactions. So how the following compounds can be prepared from 2-phenylethanol. So this is the 2-phenylethanol. We have to synthesize all the compounds which are shown here. So can we make all these compounds from this particular 2-phenylethanol? That is the question. So let us look at what are all the different compounds present. So this is a alkene. This is basically styrene. It has a double bond. So if it has a double bond, then how we can make from an alcohol? So simple dehydration may give. That is one clue we have. And we have a alcohol, which is nothing but the positional isomer of this particular one. So this is a same phenylethanol, but this compound has a positional isomer. Here we have the ethanol in the 1 position, here it is in the 2 position. So how the positional isomer of this can be prepared, that we will have to see. Basically if you have the alkene, and the alkene can be selectively converted to the whichever one of the starting material. So in this particular case the alcohol can be prepared from this alkene. And we have an aldehyde which is benzaldehyde. So this benzaldehyde can be prepared from phenyl alcohol, but not directly, because here we have 1, 2 and a phenyl ring. So we have 2 ethyl unit, 2 carbon ethyl unit and a phenyl ring. Here we have a phenyl ring and a 1 carbon unit. So that means there is a loss of 1 carbon. So if this has to be prepared from this one, we cannot directly prepare. So we will have to go through a different route in which the styrene or the alkene can be a starting material. Because if you look at this alkene, you can do a simple ozonolysis that will produce this corresponding aldehyde. So that is one another thing we can think of. And benzoic acid can be obtained from benzaldehyde by simple oxidation. So that is also possible. From the phenyl ethanol, so simple direct oxidation will produce this particular compound. So that is easy to make. This is aldehyde. So this aldehyde can be made by the simple oxidation, and the phenylacetic acid can be prepared by the corresponding oxidation of this particular aldehyde. And this is nothing but the loss of only hydroxyl group is gone. So this is ethyl benzene. So how we can make ethyl benzene from this is, we have to somehow convert this to a good leaving group and then reduce it. So we may end up with this particular compound, and it is the bromo derivative. So from the alcohol, how to get the bromo derivative? Simple reaction with PBr3 or similar reagents may produce it. So these are all the different ways how we can prepare. And let us look at the answers one by one. So the first step is nothing but the elimination, and the reagent what we have to use is thionyl chloride and potassium ethoxide in ethanol is a condition to make this particular elimination work. And then the next one is oxidation. So for the oxidation we can use a milder oxidizing agent, PCC. So the alcohol can be oxidized to the corresponding aldehyde. And the next one is conversion of removal of this hydroxyl group, simple. So thionyl chloride and LAH reduction, because the thionyl chloride reaction produces the chloro derivative, and the chloro derivative can be reduced by lithium aluminum hydride to the corresponding alkane. And the next one is conversion of this hydroxyl to the bromide. So we can use PBr3 or similar reagents. and conversion of the alkene to an aldehyde. So this can be affected by ozonolysis. So ozone and zinc and water produces the corresponding aldehyde from this particular alkene. So this benzaldehyde can be converted to benzoic acid using KMnO4 oxidation. And this particular alkene can be converted to the regiohydroxyl derivative. So that can be done using mercuric acetate, water and sodium borohydride. This conversion produces the alkene to the corresponding hydroxy derivative. So here the internal carbon is hydroxylated, and the conversion of this particular phenylacetaldehyde to phenylacetic acid can be affected by silver oxide under aqueous condition. So by that, phenyl ethyl alcohol can be converted to various different products as shown here. So now let us identify the product formed in the following reaction. Because this particular alkene is treated with dilute sulfuric acid and heat. So what are all the clues given here in this particular reaction? Dilute means this actually contains aqueous condition. That means water is present. And the sulfuric acid means it is an acidic condition. So we have two clues. One is H plus ion is present in this reaction, and two, we have a water molecule present in this reaction. We have an alkene. So when we have an alkene, we have a electrophilic proton and we have a aqueous conditions, water. So we can expect a hydroxylation reaction or the addition of OH group to this particular compound. We will have to now find out whether the hydroxyl group is attached to this particular carbon or this particular carbon, or some other reaction also occur in this particular case. We will have to see. So the first step is the electrophilic addition of the H plus ion from this acid. So this is our starting material. This undergoes H plus addition. As I mentioned, the H plus can add to this particular carbon, or it can also add to this particular carbon. So let us see what are all the outcome of two different additions. So in the second step, what happens is ring expansion takes place, because this carbocation can now be part of the benzylic carbocation, because if there is a rearrangement which occurs to produce a more stable carbocation, then that is actually possible. So in this particular case, the ring expansion actually takes place. So one of this bond is shifted to this carbon, so that is how we get the benzylic carbocation. And this is already in the benzylic position. So since it is already the stabilized one, which is a benzylic position, water addition produces the hydroxy derivative. So the hydroxyl is formed in the benzylic position here. We directly get the product. And in this particular case, after the rearrangement, this water addition produces this corresponding, this 6-membered cyclohexanol derivative is formed. So finally, what we can say is we get two products in this particular reaction. One is a 5-membered ring, another one is a 6-membered ring. So these two products are formed in this particular reaction. Let us identify the product formed by in the following reaction. The cyclohexanone is treated with sodium. Okay, what is the product obtained in the presence of an alcohol solvent? So the answer is basically what we end up is the reduction of the carbonyl group takes place, and what we have is a more stable anion radical is formed, because the sodium reaction is a single electron transfer reaction. So that is the reason we have the radical on this side and the anion here. So anion radical is formed, and the oxygen actually occupies the equatorial position and not the axial position. So this on treatment with an alcohol, basically ethanol, produces the corresponding cyclohexanol as a final product. In the summary, let us recap what we have covered in this particular session. We have studied about how to identify primary, secondary and tertiary alcohol. Basically, we used the Lucas method and the Victor Mayer method. And we also had worked out the various problems related to synthesis of alcohols. With this, we conclude this session. Thank you.